so this is 0.03 cents per square centimeter, and this is 0.01 cents per square centimeter. Now, let's say that the volume of the can is, I don't know, what size can do you want to do? Think about how you buy a soft drink can. It's measured in terms of ounces, right?
24 ounces.
Let's do a 24 ounce can then. Okay.
Yeah.
That's the way Sam rolls.
That's right.
All right, so we got a 24 ounce can, and all right, now there's a problem here. We'll get to it in just a second. How do you find the volume of inside of a can? And that would be? Yeah, height times area of the base, right? Any regular shape, three-dimensional figure like that is going to be the area of the base times the height. Now, our volume here is 24 ounces. But what are all my measurements in terms of? Centimeters. So we need to convert the 24 fluid ounces into cubic centimeters. So what's the best way to do that? Probably pick up that little cell phone and say convert 24 fluid ounces to cubic centimeters.
You make a good argument. Me doing that on the AP test.
Not gonna quite be able to do that one on the AP test.
709.765 cubic centimeters.
Okay, 709 point, go two decimal places with it.
0.77.
Cubic centimeters?
Yes.
Okay. Equals pi r squared h. So we'll just leave it like that for a minute. Now, we're trying to minimize the cost, and the cost does play into effect the surface area. So let's just start off with the surface area. Surface area would be the area of the top and the area of the bottom, right? How do we figure out the area of the bottom? It's the same as the area of the top, right? Which would be pi r squared, right? So we're going to have 2 pi r squareds. And until this year, you thought pi r round, but pi r really square. All right. And then the, I know. All right.
We have that on video.
Yes, we do. All right. This is the height. What is the length here?
The circumference.
It's the circumference, right? So that is 2 pi r. So I've got a 2 pi r h here. Now, got more than one variable here. So let's take this h and write it in terms of r. So my h is 709.77 divided by pi r squared. Are we still okay? All right. So from here, let's simplify out. Pi r cancels with 1 pi r here, so I'm just left with r here, right? And I'm going to get a common denominator here. No, hold up, not yet. I'm sorry, there's a little bit more going on here. So surface area is going to be 2 pi r squared plus 2 times all of that. Someone do that in your head. 2 times 709.77 real quick.
I got you.
All right.
1419.54.
54 over r. All right. Now, that's how you calculate the surface area. But what is it we're trying to optimize here?
The cost.
The cost, right? And how do you calculate cost from this? Well, it's the cost per square centimeter of the,
Service.
well, the surface area of the top, then times the top per square centimeter of the surface area of the sides, right? Hmm? So, this is gonna be, did I say plus? I meant to say time. I mean plus, oh yeah, plus that times, yeah, okay, I follow what you're saying. I was wrong. Okay. So this becomes, is everybody okay? 0.06 pi r squared plus, all right, move the decimal over 2 places, so it's 14.1954 over r. This is still the cost. I have not done any calculus yet. Huh?
I was reading that as cosine something.
Oh,
That makes
the
sense.
cosine of t?
Yeah.
Yeah. So to get this, I'm gonna multiply this by r over r, so I can have a common denominator. So my cost, or the cosine of t, is 0.06 pi r cubed plus 14.1954 all over r. Everybody okay here? Now, I need to take the derivative of this. Guess what the derivative is going to take into account? Or was going to require the quotient rule, yeah. So, cost prime is low, bless you,
Thank you.
times d high, which is 0.18 pi r squared, minus the numerator, 0.06 pi r cubed plus, well, let's go ahead and distribute the negative into it. So it's going to be minus 14.1954, that's 54 if you don't speak Spanish, all over r. Are we still good? Okay, so again, working right to left like you were taught to in original math classes. We get, what? Quotient rule.
Would you
This
not-
is r squared. It's r squared.
Yeah,
It's r
okay.
squared.
I was
Thank you.
surprised.
Thank you.
Oh,
So it's point, I think I may have said it and just didn't write it. Or I may not have said it, but I meant it. You just have to take my word on that. That's still the derivative of cost. All right. cleaning up the numerator a little bit, they're both pi r cubed, so these are common terms. So 0.018 minus 0.06 is 0.12 pi r cubed minus 14.1954 over r squared. Now, this is my fraction, and I'm interested in when it's 0, so I'll go ahead and set it equal to 0 here. So it's a rational expression. Again, how do we make rational expressions equal to 0? Or speaking in simpler terms, how do we make a fraction equal to 0? The numerator is equal to 0, right? So at this point right here, now think about what happens if the denominator is 0. If the denominator is 0, you fail to have a can, right? So it's not an option. So to let the numerator equal to 0, we get 0.12 pi r cubed equal to 14.1954. So r cubed is equal to 14.1954 over point. What's wrong?
Nothing. This is just like a lot. Nothing.
It is a lot. You're right. It is a lot. There won't be more than 5 of these on your test. So r is going to equal to the cube root of 14.1954 over 0.12 pi.
Your logic was really good.
What's wrong?
There won't be more than 5 of these on your test.
Yeah.
I'll be doing good to get one done in time.
No,
All right.
Ethan,
What a question.
you want 5
So
things.
let's do that arithmetic to figure out the radius.
Yeah,
Three
take
point
the exam.
3518.
3.3518 cents?
Yes.
No. Right, we're not in cent. Yeah, that's gonna be our radius, 3.3518. What's gonna be our height? Well, our height, remember, is 709.77 divided by pi times 3.3518 squared. So we get 709.77 over 3.3518 pi. And what is that approximately as a decimal?
$67.4046.
Wouldn't it be
That's not right.
pi times 3.3518 squared?
Squared, yeah, thank you, squared. I forgot to square it. So, yeah, that's gonna be better.
$21.4556.
21 point what?
4556.
4556. Okay, that's gonna be my height. That's a pretty tall can. Centimeters.
Well, it wasn't 24
Centimeters.
ounce.
Yeah, it's
Yeah.
24.
That's a big can, yeah. So 24 centimeters. All these are English sticks. Got a meter stick in here, I guess. All right. So now, what is the cost? Well, the quickest way to go with cost is to plug into that equation, so y'all do that real quick. Plug in, and all you need is the 3.3518.
Are we getting, trying to get cost? Okay.
352.
6.352 cents. So the cost is 6.352 cents. Alrighty.